For months, Elon Musk has maintained an unusual and deliberate quietness around one of Tesla's most anticipated vehicles. While he avoids giving any firm details, the truth is that something enormous is happening behind the scenes. Gigafactory Texas, Nevada, Berlin, and Shanghai are all quietly undergoing extensive reconfiguration, restructuring their production floors and upgrading equipment not for the Cybertruck, not for the Model Y, but for a vehicle that challenges almost every assumption we've ever had about affordable electric cars. Internally, Tesla engineers call it the next-generation platform. The world calls it the Model 2. And if early documents, factory activity, component shipments, and insider commentary are accurate, this car might enter the market at roughly $11,799. A number so shocking that legacy automakers still refuse to believe the math adds up, yet the price tag is only the beginning. What makes the situation more mysterious is Tesla's silence. Why is the company avoiding direct talk about the Model 2? Why does Musk dodge questions about it, even when asked directly? And how is it possible for Tesla to deliver a fully functional EV at a price most companies can't hit, even with government subsidies? To understand that, we need to explore the real production timeline. Tesla isn't publicly discussing in the radical architecture that makes this vehicle possible. When you look at Tesla's manufacturing patterns over the last decade, there's a clear progression. First simplification, then optimization, then automation. But with the Model 2, Tesla is doing something entirely new. The manufacturing process revealed in patent filings from September 2024 outlines a method Tesla internally refers to as unboxed assembly. And despite the fact that Musk briefly mentioned the concept in a presentation, he never fully explained its implications. Instead, the evidence is tucked away in patents, supplier documents, logistics data, and procurement filings, places the average buyer never bothers to look. But for anyone paying attention, the shift is unmistakable. Traditional car manufacturing involves a long, sequential line where a vehicle moves through hundreds of distinct steps. In a typical factory, the body frame is assembled first, then moved through stations where workers or robots add components, wiring, suspension, seats, dashboards, motors, the battery, and hundreds more elements. Each step requires space, equipment, workers, and time. Most legacy automakers complete 300 to 400 steps over a 20 to 25-hour build cycle. Tesla's Model 2 does not follow this pattern. According to the documentation, Tesla has reduced the process to about 160 steps. Instead of building the car as a single piece traveling from station to station, Tesla is assembling sections in parallel. This means the front, rear, interior module, battery structure, and electronic systems are constructed simultaneously, then connected only near the end of the line. This not only cuts time, but radically reduces the number of physical stations required. With fewer stations, the factory footprint shrinks, the cost of machinery drops, and the overall complexity plummets. Parallel construction changes the financial landscape of automobile manufacturing. If you can produce more cars per hour with fewer machines, fewer workers, and less energy consumption, the cost per vehicle falls dramatically. That's how Tesla is achieving production times around 10 hours per car, half the industry norm. When multiplied across tens or hundreds of thousands of units, the savings are massive. And if costs fall while output rises, Tesla can sell vehicles at prices competitors can't match. But the manufacturing timeline is only one part of Tesla's quiet strategy. The real engine of cost reduction lies in the structural battery architecture. Unlike the Model Y, which introduced Tesla's first-generation structural pack, the Model 2 uses a more advanced system that eliminates modules entirely. Engineers familiar with the internal documentation describe it as cell-to architecture, or CTA, meaning the battery cells are directly integrated into the floor and become part of the vehicle's load-bearing structure. Without modules, wiring units, connectors, structural steel housings, and dozens of other components, Tesla reduces the part count significantly. According to supply chain records, the Model 2 cuts approximately 370 parts compared to the Model 3's pack. This alone saves between $1,200 and $1,800 per vehicle. But Musk hasn't revealed any of this publicly. He has never explained the difference between the traditional structural pack and the new CTA architecture. He has never commented on the redesigned supply network or the sourcing of next-generation cells. And Tesla has made no press release about the new pack assembly lines showing up in China, Germany, and the US at the exact same time. Instead, they've quietly shipped enormous quantities of jigs, casting molds, robotics arms, cell welding equipment, and frame alignment systems to multiple global factories under generic equipment descriptions. The silence isn't accidental. It's part of a strategy. The geographic strategy is even more surprising. For years, Musk insisted that Tesla would produce the Model 2 primarily in the United States, with Giga, Texas as the lead plant. However, shipping data reveals something dramatically different. Between October 2024 and January 2025, Giga Shanghai and Giga Berlin both received specialized tooling for next-generation vehicle frames. These include multi-part casting systems that differ from those used for the Model Y, as well as new lines of high-speed conveyor robots specifically designed for the unboxed architecture. Equipment manifests show synchronized installation, meaning Tesla is preparing for simultaneous production across multiple continents. This is extremely unusual. Automakers rarely launch a new platform globally at the same time because the risk is too high. The norm is to start with one plant, ramp slowly, work out issues, then expand. Tesla is doing the opposite. If Tesla is preparing 3 or 4 plants in parallel, it indicates one intention: global launch from day one. The company appears to be planning a worldwide rollout of the Model 2 as soon as production ramps, allowing the car to hit the US, European, and Asian markets simultaneously. This approach reveals an important truth about Tesla's strategy. The automaker wants to flatten demand spikes and avoid the chaotic waves that traditionally follow a major vehicle launch. If one region experiences overwhelming demand, Tesla can balance production by shifting volume among factories. Buyers in the US Northeast might receive units sourced from Europe if that shortens delivery time and lowers logistics costs. West Coast customers might get vehicles made in Texas. Asian buyers will likely receive Shanghai-built units. With factories functioning in parallel, Tesla effectively eliminates regional bottlenecks and stabilizes pricing everywhere. And this brings us to one of the most interesting questions. Why hasn't Tesla talked about any of this? Why is Elon Musk avoiding direct commentary? The answer appears to lie in a combination of business strategy, competitive positioning, and regulatory pacing. One reason for silence is competitive pressure. If Tesla publicly reveals the exact price and timeline too early, legacy automakers could accelerate their response. Right now, every major manufacturer, Ford, Toyota, VW, Hyundai, GM, struggling to reduce EV costs. If Tesla exposes its full hand prematurely, rivals could redirect billions into catching up. Silence gives Tesla a timing advantage. Another factor is regulatory alignment. In the US, EV tax credit policies have shifted unpredictably. Tesla may be strategically delaying announcements until incentives are clarified. If the Model 2 qualifies for an additional rebate, its price could drop even further, potentially to under $10,000 after incentives. Revealing too early could create political pressure or trigger lobbying that disrupts the timing. Additionally, Tesla is managing consumer expectations. If the company gives a firm date prematurely and then faces delays, something common in the automotive world, public trust takes a hit. Instead, Tesla is building quietly until they are confident the ramp is successful. Musk repeatedly mentions that ramping production is far harder than designing a prototype. Tesla wants to avoid the pitfalls that plagued the early Model 3 rollout. Behind the silence, though, the transformation of Tesla's manufacturing approach is becoming clearer each month. Each factory modification tells a story. New battery lines, expanded shipping facilities, upgraded casting equipment, redesigned assembly halls, and new robot fleets. Every piece of evidence points to a coordinated, multi-layered strategy to build the model. It's faster and cheaper than any EV in history. Consider the casting process alone. Documents show that Tesla is using a multi-section Giga approach for the Model 2, instead of casting the front and rear sections separately as they do with the Model. Why Tesla is pushing toward a more integrated set of castings. These castings are smaller than the huge components used in the Model Y, allowing for faster cooling times and quicker cycle speeds. Faster cooling means more parts per hour, which translates directly to lower costs. A single casting machine could potentially produce enough parts for hundreds of thousands of vehicles per year. The battery cell lines tell an equally compelling story. While 4680 production has been the focus in recent years, the Model 2 appears to be using a different cell format optimized for fast assembly rather than extreme energy density. The priority here is affordability, not range. But Tesla's software efficiency and power electronics improvements make these smaller packs sufficient for real-world driving.